Howdy everybody in YouTube land. Welcome to part 2 of the Toshiba T1000 restoration series. So now that we have the parts in here, before I get to the floppy drive and all of that, I need to start working on the capacitors and all that fun stuff. Now that I have the right capacitors in here, I want to go ahead and get the capacitors replaced on this screen first, since I have the replacements for these now. So let's go ahead and do that. Just like that, I have a brand new set of capacitors reinstalled on that display. I only saw one, maybe two leaking here. The rest of them were okay, but they all had to go. So I got all the old ones over there now, and so this display can get put back together. Now, one thing I noticed is this display uses electroluminescent. That's an EL sheet in there, that pink wafer. So this is not a CCFL display. That's an EL display, which is kind of neat actually. So, kind of an interesting tidbit of information. And that's the part number to the display if anyone's curious. But that's done now, so I'm going to go ahead and get this guy put back together, and we can start working on the motherboard and getting the correct parts put in there. Alright, so now we need to pay attention to the logic board here. So what I've done here is I've removed this transistor that I put in there before, and now what I'm going to do, I don't know how well it's going to work, but what I'm going to do is I picked up these. Now these are not recommended for new design, but the IRF U5410 I believe should work in this thing, no problem. So, and it's in the correct form factor that I need. So I'm going to use this transistor to sub the one that was blown up. It should work fine. And also, I'm inclined to leave these capacitors alone because they're probably going to work just fine. But I do have, instead of these 47s, I do have the proper 56 microfarad capacitors now, which are, let's see, or not. Oh, there they are. Low impedance electrolytics, 56 to 35 volt. So those will work in here. So I can get those replaced with the correct ones and then get the correct transistor put in here. And then I think we can move on to the floppy drive. Alright, so the new transistor is installed and the new proper capacitors are installed. I left these alone because they're fine. So that is complete. So let's go ahead and try to power it on and make sure it still powers on. Yes, it does. It's still running. Okay, so we didn't kill anything. So that's good. Just fingering around for heat. Okay. Alright. So I'm going to leave that alone now. I went ahead and put this guy back together too. So this is just an empty shell now, but at least I'm not going to lose any of the parts. Alright, now that the board is basically done, it's time to take a look at the floppy drive. Alright, so the next thing on our list is we need to tackle this floppy disk drive. Now, I've been doing some closer inspecting of the drive. It's that Citizen drive, U1DA-00A. It's only a 5 volt drive. It doesn't need the 12 volts for anything. But what scares the crap out of me is I'm looking at this drive and guess what? We have a spindle, but I see something down in here. See that? That's a motor. You know what? This is a belted drive. So there's a belt that runs here, just like all of the other Citizen drives. Oh, I'm going to bet that this belt is probably bad. So might as well tear it apart and see what we got going on. Because here's the thing about this machine. If you can't use the floppy drive, you really can't use the machine because there's no hard disk storage. So we have to fix this. And if not, the service menu at least has the pin out where we could just shove a Gotek in there. But I'd rather fix the drive. So let's get the drive fixed. This is a never-ending battle. So I took the lid off the drive, and this thing has, it's an interesting design, but from what I can tell, as soon as I took the lid off, I wiped my finger on this ribbon cable and it's wet. So once again, it's like, okay, well, why is this drive wet? Now we have a belt in here, as I suspected. I don't know, you see that belt's toast, so we're going to have to replace that belt. But perhaps more importantly, look at all this. There's cap goo all over this board from these capacitors leaking. There's a 22 16 volt, 22 16 volt, which I have those. Yeah, this is the head alignment. See, removing this is going to be problematic because that is going to want to come with it. And that, if you mess with that at all, you'll throw the head alignment off. Yeah, that is, what kind of design is that? That is not going to be fun to realign the head. This is looking more and more like a Gotek job. I do not like this design. Then we have, that's still all jammed up, which I got to figure that out. Alright, well, no, I got to get it out from the bottom. Well, that's why the drive is jammed. That took a wallop from hell. Yikes. I don't know if I want to be able to flatten that out. That is going to be a good question, but that's why it's not. You would think I would have seen that from the outside because the case is not damaged. I wonder how in the hell that happened. It's like someone jammed a screwdriver in there and just pried on it. That's weird. It'll be a miracle if this drive ever works again. But I got it. So it was getting hung up here. So I was able to bend it up and push it back. So I had to remove the button. That way the carriage could get pushed all the way back. So this would slide out. And I had to carefully get it out from underneath that head. So I got that out now. That allows me to service what's left of the belt, which is not much. It's kind of just gross. Petrified. Yeah, I gotta see if I even have one of those. I doubt it. Yeah. Anyways, so I got this version for the laptop drives. Or I guess technically it's a laptop, but it's not the same thing. So, yeah, see, it's jammed up again. It's just, yeah, it's just crap. Anyways, so I gotta get that out. I have to get the head removed, which means I have to realign the head because this all has to come out of the way to get this board out. So, I mean, if this drive wasn't bent all the way in, where I've got to hammer it back out, and you know, stuff like that, I could probably just clean it up. But look at all the cap goo, the liquid. Yeah, so it's gotta come out. This whole board has to come off. So that can't happen until all this crap's out of the way. So let's get all that out of the way. When I get it put back together, it's probably not going to work right. If at all, we're going to have to try to realign the head. Because there's the track 0 sensor. But the thing about it is, there's a stepper motor. So this has a certain step angle. Like if I push on it a little bit, you see how it, like, it's hard to explain. You see how it just jumps a little bit at a time? Well, those jumps are predetermined by the poles in this stepper motor. So this stepper motor will rotate to determine where those steps are. So, yeah, I have to... I've got to admit, this is the most asinine floppy drive design I've ever seen in my life. So, this whole head stack had to come out to get to this board. This had to come out, which is over here. All of it had to come out. Stepper motor had to come out. What I did do is I tried to make a couple marks on the motor and the plate, so when I get it in, I can get it in the, somewhat in the ballpark, but it's not going to be right, of course. So, man, what a pain. So I'm in the process of taking the board out because I want to get this thing to a point where I can actually work on it, but I also have to flatten out this bent thing. But that's going to have to come off so I can pull the hub. Alright, so now I've got the board separated from the unit. So here's the metal cover, or the metal base. So I've got to bend that out somehow. I'm going to have to use a hammer and a board, and yeah, I'm going to have to figure that out. Anyways, that's not super hyper extra critical. But this, though, now that I got the board out, I can actually take a look at the real problem we have going on here is all of this capacitor leakage from the surface mount electrolytics. They're going to have to get washed and removed. So, well, I had little hope of even saving this drive, but that little hope went to basically no hope. Because, well, I was trying to flatten this guy out with the hammer, but only made it worse. And I couldn't bend that out. And then when I tried to bend that out, it twerked the side, so this whole thing was wobulated. So I just said hell with it and then hit it one time with a hammer. It's done. So I already got the caps installed, but oh well, it is what it is. Well, unfortunately, we're going to have to come up with a different solution because this is the Citizen U1DA drive. This number varies based on the configuration, but they're all U1DA, right? I can't find this drive anywhere. Nothing on the used market. And Toshiba was probably the only laptop manufacturer that did this, but what I did find out was a lot of samplers, electronic, music samplers and stuff like that used these drives, the exact same ones in the exact same form factor. So that's why they're nearly impossible to find, because they get swooped up by the music instrument market. Anyways, not that big of a deal. The problem with these drives is they're physically the size of a desktop drive, but they're slim. They're not as tall as a desktop drive. So as we saw, the floppy drive is a complete disaster. Now, at this point, it's a matter of trying to figure out what I'm going to do about that. I still have the top lid. I've already got the floppy drive parts all just thrown in a baggie. I still have the top lid and ribbon cable, but this is like a 26 pin proprietary Citizen standard. So I don't know what I'm going to do about that yet. Obviously, I can't get the drive or any of that at the moment. So I need to figure out how I'm going to make this work with a Gotek, because I have a Gotek on the way. And what I'm probably going to do is I'm going to pull this connector, because this connector is through hole, right? So I'm going to pull that connector and put headers in there and see if I can't make something to do it that way. So I got the floppy connector removed. That way, that allows me to install a header here and potentially either install a header there or rewire a standard floppy cable ribbon straight to this port, or I can just use DuPont wires, something, because I want to try to put a Gotek or something here, because trying to find the exact floppy drive, it's impossible. It's unobtainium. I can't get it. So this is the next best solution. So I pulled that out. I'll just keep that off to the side so I don't have to worry about that. And there we go. We now have the headers installed. Ugly, but with the proper DuPont wires, we should be able to get what we need done to make this thing work. Now I just have to wait on Gotek to come in. But that's not the only thing. I can test the Gotek, but I'm going to have a 3D printed thingy made for it so I can actually put it in here. So fast forward a whole lot of time. We're talking a year and a half, maybe. I don't know. So it was about a year and a half ago. I was working on the first parts of this Toshiba. So remember, we had a complete disaster with the floppy drive, and honestly, I was experimenting around to figure out maybe we can add a Gotek, but I gave up on that because, again, we have to have a custom mount printed and installed to fit all the electronics, which I don't have the capabilities of doing. So I put the whole thing aside. Fast forward about a year and a half, and a wonderful person who watches my channel, who was also at VCF Midwest 2024, gave me this machine. He had it in a stack of laptops for parts. I was flabbergasted because I wasn't really expecting that. But so this one is clearly a parts machine. We got busted hinges. We've got like a completely yellowed floppy drive. We have the battery is solid yellow from heat exposure. Does not have the modem, but who cares about that? And yeah, Fisher Imaging Service Training, whatever that is. Missing feet, but that doesn't matter. Missing memory door cover, all of that stuff. But you know what? That's fine, because this is a parts machine. I am going to take the floppy drive out of this one, since the metal is not all bent out of shape, and try to, once again, fix this one. We saw how much of a nightmare it is to get to the belt and all the components. So we'll see if we can get that one fixed instead. And if not, then we'll go through the whole Gotek method. But also, I think, besides this thing being completely destroyed, keyboard's very, very dirty, nasty, seen better days. But the screen, let's see, because remember, if you looked at mine has a little bit of screen cancer developing on the corners. Luckily, it's not in the viewing area, but this one, I think this one is actually good. The polarizing film is in good condition. There's no damage there. Oh, maybe spoke too soon. It's damaged right there. But that's not much. However, I don't see any screen cancer on this panel. So I can put this in my spare parts bin just to have it on hand. But otherwise, let's just tear this thing apart and see what we got, because I need the floppy drive so I can finish that project. You know, it's a great sign when these are just falling outside of your floppy drive. Yeah, okay, well, this is what I really needed. Hopefully I can fix that instead of destroying it like the other one. Anyways, so this guy here, I will say this, even though this one's beat up and missing a bunch of parts, the actual hinges are not bad. I mean, yeah, it's screwed, but if you look at the standoffs, they're intact. There's no problems with the standoffs. So these just kind of flopped around and fell out, but I honestly think those are fine as well, because there's literally a hole that goes in here. So I think this machine could be salvaged. Yeah, this drive is gross, but I'm going to try to service this without moving the head off of the mechanism this time. So yeah, this one's gross, this one's gross. One of the two fell out, and they both actually fell off the board, and then I removed this one. So those are two 22s at 16, and this is a 1UF at 50. So we're going to change all three of those and clean it up as best as we can with alcohol, because otherwise you can't get this board out, not without removing the head and blowing the alignment. There was a broken trace right there, but I got that patched up. So hopefully this drive works. Now remember, with all the struggles I keep having with Toshiba, is trying to find a belt that keeps the servo loop happy. Hopefully we can find something. The original belt is still intact. It's a little bit stretched and gooey, but it can be measured to try to find something close. Well, unfortunately, I don't have a belt that will fit. These Chinese and Wonder Muffin kits do not have anything remotely close. Now, this is a square belt, which won't work because it rides the shaft. Now, the original belt is about 2.6 millimeters wide, or 3/16, something like that. The closest I can get today is 3 millimeter, which is fine for this tape path, or well, disc path. There's plenty of space there for that. Now, the important measurement is how long it is. So this belt is a little bit melted and stretched, just a tiny bit. It's not off by far, but it is stretched. And we have roughly 226 millimeters wide, little fraction over, but that's stretched. So it's probably really only 223 wide, 222 wide, something like that. Now on turntableneedles.com, I can actually get an 8.6 inch belt, because the problem is we have 8.6 and then it jumps to 9. 9's too wide. So 8.6 gives me 218, which is a little bit short. That puts me about right here. So it's going to be stretched a little bit. I don't know how well that's going to work. If I do 9 is 228 millimeters, almost 229, which puts it way out here, which is even more stretched. So we're just going to have to go with this one and see if it works. Only one way to find out. I was measuring off the belt, and I have a solution coming for that. But in the meantime, I'm sitting here looking at this, like, this parts board, I say parts board because that's how I got this machine. This board doesn't look like it has any of the leak damage that my original board does. I'm sure these caps are bad and they're starting to leak, but it doesn't have the same damage my other one does. So I'm thinking here, what if I just fix this board instead? Just recap this board and use this board for my rig once I get the floppy drive fixed, and use that one instead with the other machine that's in better shape, and just have a good machine. But honestly, there's enough parts here I could probably, because as I was saying earlier, the hinges aren't really broken. They were wallered out and everything got loosened up, but they're not really broken. So I could actually fix this machine and use it without the floppy drive, of course. Because the thing is here, I mean, yeah, it's a parts machine. I got it as a parts machine, but it's not broken enough and in bad enough shape, once I determined that the hinges actually weren't that bad, to just throw it in the trash. It's hard to justify that. So I'm wondering if I can just fix it up and then sell it or give it away or something. I don't know. I'll figure that out. Because here's the thing. Someone had sent me this recently. And this, it's not, the holes are not in the right spot because I got the wrong measurements. But this is the Gotek 3D printed, whatever you want to call this thing, that fits this hole. So I could actually, I mean, it's I don't know, PLA super cheap black stuff. It's not white, but that would actually work in this machine. And I've already got the other motherboard wired up here to use this Gotek. So I think I want to do that. I think I want to fix mine with the original floppy drive with this motherboard, and then do the second one out of all these parts with the Gotek. Because you know what? Why not? It's already here. If this board is good, and there's nothing wrong with this board, why not? It's kind of hard to justify throwing it in the trash. Besides, if I can fix this machine with a Gotek, someone may want it, and I'll kick it down the line. Here's the amazing thing. So these, what are these? Those are SXF series, but these are the only two caps showing any signs of leakage in this cluster, and then there was one over here which was showing leakage, and it wasn't even really leakage, it was just drying out. You can kind of see it like right here, but these are the only two showing it, and this one was just starting to, so that's actually not bad. It's surprising. These were fine. If anything, this inverter slash LED board is the one that's leaking the most, because you can really see it in there. And you can see it under there too. So these have to go, unfortunately. But compared to the motherboard, this is minor. There we go. It's all nice and recapped now. Clean, not spooging everywhere. So, all right, I'm going to go ahead and take these. This one is not quite as important as this one, but I'm going to take these and start putting them back into the better one, the one I was working on originally, and we're going to test this guy out and make sure that the circuitry all works fine, because I want to build the best one out of the two and then take the other one. I was going to part it out, but I think I'm just going to turn it into a working machine, just not as good as this one as far as quality is concerned, but at least it'll be there instead of being scrapped. So that's what we're going to do. The freshly recapped logic board and inverter board in this particular case. So here we go. Let's see if this works. That is a no. This motherboard is dead. Alright, so we're back to the original board. Let's see what it does. Well, it doesn't turn on, but at least it tries. Unlike that one over there. But I'm trying to use this power adapter, which it may not be enough amps anyways. I probably need to put a bigger, run the bench supply. I was trying to avoid using that bench supply, so, you know, let's just fire that up and see what happens. Alright, so yeah, this thing has developed a problem just sitting for the last year and a half or so. Worked fine, but it doesn't now. Because it's been a year and a half, I think I found the problem. See, the battery has to be in here. All these early Toshibas, I think, have to have the battery. Well, this is the parts machine, but this is the good motherboard. So, the one that worked a year and a half ago. Seems to be working fine for the power of the battery, if I'm sending the 7.2 volts in here. But it won't run off the DC adapter, it just shuts down. So that makes me think this thing needs its battery, just like the Toshiba T1100 and the T1000, all of those. This is also a T1000, but it's the SE, the second edition model. So you wouldn't think it needs the battery, but I guess it does. Actually, I had to pull up my old footage, and sure enough, it is running off of the battery input. Because notice I have this yellow cable, which is over there. So it was powered from the battery. This is a year and a half of, memories I'm trying to go through. All right, so yeah, that makes sense. A lot of these early Toshibas, you need the battery in order for these things to work. So there has to be a way to bypass that. I'm pretty sure there is, but news is though, even though the EL sheet is a little bit dim, but the display from the parts machine actually works flawlessly. So that's good. That's a good thing. So now we just need to go back into that motherboard, which won't turn on at all. This one at least tried to turn on. This one won't. So I'm going to go back to this one, plug the DC side into the battery again and see what happens. All right, back to the other motherboard. Let's try this again. Oh, it turned on. So you gotta have the battery. That's what it is. Alright, so let me turn the brightness up. Ooh, that's not the brightness. That's the brightness down, that's the brightness up. Same screen. Alright, so yeah, if you look, there's besides a little bit of a polarizer damage there, the screen works fine. There's no sign of screen cancer, there's no sign of bad pixels, lines. It's a good screen. The EL sheet needs to be replaced. But other than that, it seems to be good because the EL sheet is very, very weak on this one. But it's working. So, motherboard's good. It posts. It's working. All right. Okay. So what I want to do next is I want to get the other inverter and other screen because the other inverter. This is the inverter that I was using a year and a half ago. This is that inverter. So I knew it worked. I need to go test the other one now. So here we go. Turn power on. Power on. There we go. Yeah, I see the difference right away. That screen's a bit brighter. It's hard to tell in the camera, but it is. It is a bit brighter. And actually, you know what? Hold on. The screen cancer disappeared. It's not there anymore. What? Because remember, it was getting close, but it's not there anymore. What in the hell? No, I still... Okay, never mind. I still see a little bit right there. The screen cancer, but the rest of it's gone. There was some over here too. At least I remember. Now the EL sheet on this one is a little bit brighter than the other one, so this will probably be the one that I keep. But yeah, inverter works. We're good. So perfect. We can move on. So now I just need to get the floppy belt and get all of that fixed. You want to know something amazing though? That battery is holding a charge and it's running the machine. So that's quite impressive. So we're going to shut that off. So the battery actually holds a charge. Now this is not OEM, so it's been replaced before. And because it had to be. I remember it because this thing won't run without the battery. So anyways, at least we know we don't have a board problem, so we're good there. What I'm going to do is experiment with this one a little bit because this is going to be my parts board. Because what I want to do is see if there's a way to hide this, like up under that. I don't know that there is. But what would be cool is figuring out some way to hide this in here somewhere. I don't know exactly where. Okay, I gotta be careful because I can't just put it anywhere or I'll irradiate EMI into the digital circuitry. So I've got to figure out where to put this. I just don't know where that is yet. The downside is pretty sure all the current for the machine will be flowing through this module. So I need to make sure this module is enough to handle the load without too much heat. I think it should be. Because on a good day, this board doesn't pull more than a half amp with the screen and everything turned on. You know, unless I've got drives plugged in, the floppy and all that going. Let's just, for the safe side, we're not going to pull an amp from the 12-volt supply. So I think this should do it. But I got to find a place to put it. Because I still want to leave this in there. But do I, though? Do I really need this in there? Maybe I don't. Because if I take this out... I mean, I have a screw that goes in here from here. But I can put the battery in there just to kind of hide the hole. Leave this off. And just kind of put this guy right in here somewhere. I don't know. We'll figure it out. Or perhaps I can hide it up in here. Then it's out of the way. But I can't hide it up in there because if we look at this, the way this is set up. I don't know. This is a feat of gymnastics because the way this is set up is that goes here. So I can't like put that there because that's going to be in the way, right? This is the inverter for the EL sheet. So that's important. Now if I tried to hide this like up in here, problem with that is it's going to be in the way of all this because all of this tucks itself up in here, leaving pretty much only this area here to put that driver. That's really the only spot to put it. And it should just fit without this if I leave this out. So it literally just fits under there. There's the inductor. So it will fit in here as long as I leave this one out. It'll fit in there. And actually what I could do is hollow out this battery or make a 3D printed case like this that goes in this spot, because what I'm thinking is I could hide the XT to IDE circuitry in here and then slide that in right here like that. So that's now an XT to IDE interface with like a compact flash card or whatever. And then we just loop it back to this plug right there. There's just a piece of a PCB or whatever, and it's all one piece. So then this is all hidden by a 3D printed piece of plastic or something, and this becomes your XT IDE. I don't know. It's just things to think about, but it will fit in there like that. Now you're probably asking why a DC to DC converter. Well, here's the thing. This thing is designed to run off the battery, so the reference voltages and most of the energy comes from the battery. The 12-volt circuit, I've chased it through. It goes through these diodes and some other stuff, and it just kind of trickle charges the battery. But when it kicks on into full charge, it kicks this circuit here on, which then starts dumping charge in here. But ultimately, it runs off of this. So you could say, well, I could take a jumper wire and just take the 12 volts straight in here. But here's the thing. It's not designed to run at 12 volts. It's designed to run somewhere between 7 and 8. So the other problem is I could do a jumper wire and I can put a Zener diode in there to keep it at 8 volts. But that's just going to burn a whole lot of heat and cause me a lot of problems. So instead, we're just going to use a adjustable DC converter, and we're going to provide the roughly 7.5 to 8 volts off of this blocking diode so you don't get charge back in here to run this board. So now, unfortunately, now that I stuck the tape on here, it no longer fits. I'm running into the top of the case. So what we're going to have to do is remove these capacitors and put some through-hole ones in there and fold them sideways. Now, these capacitors are grossly oversized because it can take up to 24 volts input, and I'm only giving it 12. So I can drop this down to like 25 volts or even 16. And the same thing over here, 220. I can drop that, since I'm only running at 8 volts, I can drop that to a 16 volt or a 25 volt as well. And bend them sideways, and I got to do the same thing with this adjustable potentiometer. That way I can get it out of the way and tape this down and actually have room. So, does it work? No. Nope. Well, let's see what the voltage is doing at least. Check the output of the diode. What in the world? It's being weird. There it goes. 8 volts there. What's on the battery side? 11 volts there. I wonder if I need a load on that battery side. It's trying to turn on, but it won't actually turn on. Probably need a load. Now, if I go straight into the converter, bypassing the 12 volts entirely and just putting it straight in the converter as if it were the battery, works fine. Now it knows there's no DC input, but it's, I don't know, that's weird. It won't run if it senses 12 volts here as well. For some reason, it won't run. And I've tried to add, I've got some like 1 k ohm resistors. I put some in parallel to try to bring this load down to simulate that there's a battery load there. Nah, didn't do anything. So, weird. So, I've been down this rabbit hole for several hours now. So, what I ended up doing, because this board, I took this DC converter and put it on this board, and it seems to work fine. Where, with the 12 volts connected. This one doesn't. It won't run. And it will, as long as I start it before I connect the 12 volts in, which is hard to do. I have to run a wire. Anyway, so I decided to do a spreadsheet of voltage charts from the bad board and the good board, attempting to start it up with the AC only. And then I got values with it in standby with just the AC only. And then I did the DC while it's running. And my voltages and everything look basically the same. The only difference is the AC startup attempt on the bad board is much, much shorter than it is on this board. This board's a lot more tolerant. And then I'm like, okay, well, nothing's really conclusive there, so I figured I'll just grab this battery since it kind of holds a charge, put it in there, and do my measurements with the battery and the 12 volts. And it's actually working. It's charging the battery, it's floating the battery, no problems, just like this one does. It's all working fine. So there's probably not a fault with this board at all. I'm just chasing a ghost. But I did just notice something. I'm like, well, the only difference between two boards is, well, this board, I was just substituting some random value capacitors trying to calculate close differences because I didn't have the right ones on hand. This one, I had the correct ones on hand. But then I realized I actually dyslexically fucked this one up because look. So this, I have a, what is that, 1800 and 212s? Well, the originals, I have an 1800. I have another 1800 and a 1200. I screwed up. I'm supposed to have two 18s and a 12, not two 12s and an 18. Crap. That's probably why I'm having some weird issues with this thing. I got the wrong caps in there. But to be fair, I do over here too. I got a 1200, which the 1200's in the right spot. That's where it's supposed to be. But I needed two 18s and I didn't have any. So I did a 22 and a 15 because these are in parallel to get somewhat close. Where, whoops. Since these caps are in parallel, if you do the math, that's 2400 microfarads right there. When I need 3600 microfarads, right? Well, over here, I got a 22 and a 15 in parallel, so that's what, 37? So the microfarad over here is correct. This one's not, so I gotta flip-flop these two back around and get another one of those for over here. That'll do it. That's a big whoops on my part. So this whole rabbit hole was caused by me making a mistake. Hey, you know what? I'm human. We make mistakes. Unfortunately, changing those capacitors really didn't resolve my issue of trying to do my shenanigans with the DC converter while 12 volts is applied. It doesn't like that on this particular board. So, but I know the board works fine because it works fine with the battery and it does proper charging and all of that. So what I've done is I've removed the filter choke to remove the 12 volt from the circuit and then just pick the 12 volts off right here to run this converter, which is feeding back into the battery connection. So the converter is what's powering the whole machine. So the machine thinks it's a battery that's installed, but it seems to work fine. Now if I turn this off, that's going to flash this DC light potentially. Well, no, it didn't do it that time. Came on. Let's try it again. Because what will happen is it'll flash this DC light because it thinks there's still a sense wire somewhere. It thinks the 12 volts is there and is trying to charge a battery that doesn't exist. So, anyways, it seems to work fine like this. Like I can unplug the power, plug it back in, turn the power back on, and it's doing exactly what I need it to do. And it's running off the 12 volt wall wart. So I'm happy with that. Well, we're still waiting on the floppy drive built for the original floppy drive on the other one. So just as an effort to keep things moving along while I'm waiting for that, I'm going to go ahead and put this one together. So this was the busted up parts machine that was really dirty. I just got done cleaning the case and actually it came out really well. So, but this is the other motherboard. This one's just going to use the original battery because the original battery still holds some charge. So I'm just going to leave this one basically stock with the exception of we're going to do the Gotek modification. Well, attempt to anyways. So we're going to do that, and hopefully that actually works. So the only problem is the original print that this person did for me, the holes don't line up. I tried to measure them as best as I could, but you can tell where I just did the paint marker that how off it is, because if I try to like line it up with this guy here, which this is the floppy drive, the width is correct, but the holes do not line up. If I try to line them up, they don't quite make it. They do this way though. I don't know. I'll have to play with it and see how it lines up, but I don't think it does, because if I try to put it in here, it doesn't quite fit. Not quite. It's there. It's really, really close though. Really close. I don't know. We'll see. We'll get it in there. Yeah. The fun part is the gymnastics required how to get all of this big wire fluff to cram into the space of all of this while still be able to get the top cover on without this bulge up here. That's going to be some fun times. But you know what? It's working, kind of, I think. Yeah, there it is. Alright, well, unfortunately that's not going to work, because I just crammed the lid on, and look at this. We've got a clearance problem inside here. So that DuPont wire idea, which I thought was going to work, is not, because it's running into right here. And you can tell too, because it's not coming close to the circuit board. Like if I flip this around, oh, it's not quite making it. Not quite. All right, well, that's okay, because I need to make sure that the flash floppy stuff will even work with this machine, because if not, there's no point. So I'm going to test it and make sure it works, because that is not going to work. Or I could, another thought is to just take those headers out and cut the DuPont wires and just solder them directly to the board. That's always an option. Huh. There we go. Look at that. It's formatting. The floppy drive emulator is working. Holy crap. It's impossible to see this screen. So, now in order to make a Gotek work with the Toshiba T1000se, it's pretty straightforward. You just wire up all your grounds and power. And it's just pretty much signal for signal. You got to make sure that the S1 is set, JC is set, and then drive select 1 or A is got the right one. I had it in B, I had to move it back. And most importantly, the Citizen standards, you have a media signal and a ready signal. The ready signal has to be grounded or it won't work. The media signal, I left it floating, but the side effect to that is it cannot tell what type of disk is formatting. So if you want to format a 720K disk or a 1.4 megabyte disk, it won't be able to auto-determine what that is. But that's not a big deal, because you can go into format.com whatever and specify what you're formatting it, and it'll work fine. Now the C drive, unfortunately, looks like it is a ROM drive. So that's what's in ROM. That means to use like an XT IDE, it's going to override the int13H extension, which will replace this with its own driver. Yeah. Anyways, not a big deal, but it does work. I had to pull the headers off and then solder the DuPont wires directly to the board, but that should work a bit better. Well, let's hope anyways. The last thing that needs done here is cleaning this nasty keyboard before we do a final test, because this thing is just absolutely disgusting. So I just Yeah, all the finger dirt and grease. Ugh. So this has to be clean. Got the keyboard keys all washed up, which this was laborious because first you have to make alphabet soup with this stuff. But not only that, once you get it all washed off, then you got to rinse them all. And then, well, what I should have done was have an alcohol bath, but I don't have it. So what I had to do was heat all these keys up and just get them hot enough to try to evaporate the water, clean them all off. But also, I have to take the compressed air and blow into these springs because water will sit in there and it will just corrode those springs away. So you got to blow all those out too as quick as you can and then let them all dry, which looks like I got the majority of them dry. Now this is one of those hybrid mechanical style keyboards where it's rubber dome, but the rubber dome, even though that's acting as a suspension, it's not what touches the key, it's these springs. So it's kind of like a rubber dome slash spring keyboard where the more modern stuff is just pure rubber dome and scissor. But anyways, I kind of like the way this types, even if it is kind of a hybrid rubber dome keyboard. So all the keys are done. Now I just got to get some Q-tips and try to clean this up a little bit because you can't wash that. You'll destroy the membrane. The problem is the membrane is heat staked in there, so it's not coming out. Now that's much better. It's a lot cleaner. I took the plastic off too, and I mean there's some scratches and scuffs and stuff like that, but that's okay. I don't have that crazy dirt ball caked in 35 years of nasty anymore, at least, so all good. So I can go ahead and put that Toshiba T1000 parts machine back together. And what I thought was going to be a parts machine to fix the other one turns out to be an actual pretty decent machine. So that's how this video became two machines instead of just one. So we'll get that out of the way and we'll work on the next one after we make sure all of this is good. Yeah, that looks much better. Nice clean keyboard. It's all screwed together. The whole bezel itself is clean. Now, I did order a new EL sheet for this. So I'm going to leave these little inserts out because we're going to have to get back in here again anyways. And the hinge is tight. It was just the screws that backed up. So we're good. Turn the power on. There we go. Memory test. We're good. This thing is actually working fine. And I'm going to go ahead and put the... USB stick in here, which has the floppy image on it. So if I turn this off and then back on, it should boot from it, including the change I did to the auto exec bat yesterday. Looks like it's reading, and there it is. So now my prompt is good. A drive. So we are working. Floppy drive emulator is working. All of that's working. So let's check the keyboard. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Yeah, that works. Looks like all the important keys are working. Yeah, it's all working. Caps lock works. We have there's a num lock too, but I don't remember where that is. So anyway, so here, oh, there's a function key. Let's see if that works. Yeah, it does. I'm gonna make this one the end of part 2. I gotta split this into 3 parts, I think, because we're still having problems with Hurricane Helene and stuff's just not arriving yet. So it's going to be a while before things actually start to trickle into this area, supplies-wise. So I'm just going to go ahead and wrap this one up since we have the flash floppy and all that stuff working perfectly fine. And this one, it's crazily enough, the battery is holding a charge. So I'm going to leave this one alone. This was the parts machine that is now fully operational. And we're going to pick this back up in part 3 when we get the belts on the floppy drive and actually fix the floppy drive properly instead of what happened earlier. So fix the floppy drive properly, and then we'll get the second machine, which was the original machine, working. So we'll have 2 of these guys. So anyways, this is the end of part 2. If you enjoyed this video, don't forget to hit the like and subscribe and all that fun stuff. Please feel free to leave a comment if you have one. Until next time, guys, thank you for watching.